I welcome everyone to this session with me. I'm Teacher Kamanga from Diamond Learning Academy. I'm the tutor for science. Today we'll be looking at an atom. We want to understand how the atom is made up and also what are the detailed structure of the atom. In this case, by definition, we're saying an atom is the smallest particle of an element that can take part in a chemical reaction. Now, what we need to understand is that an atom is very tiny and it is made up of 3 subatomic particles. Now, the 3 subatomic particles that we're talking about are the proton, electrons, and also the neutrons. What we need to understand is that the proton, electrons, and also neutrons, there are differences in terms of the masses, and also there are the differences in terms of the charges and also their location. Starting with the protons, the proton has a positive charge. In this case, it is very different from an electron and also a neutron. And also we know that the mass of the proton, it is 1. So the mass number for a proton, it is 1. Then if we're talking about the location where we can locate the protons in a nuclear structure, we are finding the protons in a nucleus. We'll basically look at how the structure of an atom it is being arranged as we proceed. Now, what we need to understand at this juncture is that the protons are located on the nucleus. Now, when you come to an electron, the charge of an electron it is negative. Also, when you come to the mass of an electron, it is 1 over 840. Now, the location of an electron it is found in the shells or the energy levels. Therefore, that is the location of an electron. When we come to a neutron, the charge of a neutron it is 0 or the neutron has no charge. When we come to the mass number it is 1, and also basically we can still locate the neutron from where we had located the protons, which is basically the nucleus. Now, this is giving us an understanding in basically the location and also the mass numbers, including the charges of these 3 basic atomic particles of an atom. Now, when we come to the structure of an atom, what we want to understand is that we want to understand now the specific location where we had mentioned that where we can locate the 3 subatomic particles. Now, when you look at this structure, we're just seeing the structure of an atom. What we are seeing here in between, it is what we call the nucleus. Therefore, like what I've mentioned, that in the nucleus, we can still locate 2 subatomic particles of an atom. These are basically the neutrons and also the protons, of which I've mentioned that when you come to a neutron, this one, it is neutral or it has no charge. When you come to a proton, it has a positive charge. Then also, proceeding, we have what we call the energy levels or the shells. This one is the first shell, and this one is the second shell. Now, when we come to the shells or the energy levels, this is where we can locate the electrons, of which we have said the electrons, their charge, it is negative. When you look at the structure, we can still give the symbols for these particular subatomic particles. For instance, when you come to an atom, if we are to represent an atom with a letter X, in this case, in finding the specific locations of an atom, we are simply going to present the proton with a letter Z. Then a neutron, we're going to give it a letter N, while the mass number that we would also have to locate, we're going to give it a letter A. Now, since we have said we're going to represent this one as the structure of an atom, we are going to say here, we are going to put A, then here we are going to put Z. Now, what we are seeing, it is just the arrangement of the the subparticles of an atom when you go to an element. Therefore, this simply means the mass number, while this one simply means the proton number. What we need to understand is that an atom, it is neutral. This means that an atom has no charge. Therefore, the number of protons and also the number of electrons, they are equal. If we have the number of protons being 2, this simply means also the number of electrons, it is also going to be 2. Now, how can we calculate or find the number of protons, electrons, and also the neutrons in a given atom? Now, we are going to calculate that following this structure that we have been given. In this case, when you talk of the mass number, since we have also mentioned that at the nucleus here, that's where the masses of an atom are concentrated, meaning that the addition of the protons and also the neutrons give us the specific number which is called as the mass number. To make it simple, we're going to say A, which is the mass number, is equals to Z, which is the proton number, plus N, which is the neutron number. Therefore, when we add the two that we can still find at the nucleus there, the neutrons and also the protons, we're able to have the mass number. This equation, it is very important because we'll be using the same equation in order for us to be able to calculate and also trying to identify the numbers of the neutrons and also the protons in a given atom. For example, if we are given the mass number to be 10 and also the proton number to be 2, then we are told to calculate the number of neutrons in this particular atom. What we are simply going to do is just going to replace in that particular equation. In this case, we are going to say where there is A, we put 10 is equals to, where there is 10, where there is Z, we are going to put 2 plus N. Since we want to locate the number of the neutrons in that equation. Therefore, we are simply going to shift these two, cross the equal sign, and shift it to the other side. Since it is a positive number, according to mathematics, when a number crosses the equal sign, it changes its sign. This means that if we have 10, since this one is a positive, it is going to change to a negative. Therefore, we're going to have 10 minus 2 is equals to, we have remained with the n. On the other side, it's equals to n. Now, when we minus 10 from 2, we're going to have 8 is equals to n. In this case, we are simply trying to say that in the atom making up this element, we have 8 neutrons. This was just an example on how we can be able to use that equation in trying to calculate the number of protons, electrons, and also the neutrons. Thank you very much. We're yet going to meet into another session.